I would recommend you for the homework, you kind of draw out what I just did, like throw in some entries just on paper, see the association. Just kind of like visualize it as Excel spreadsheets. I think if you can understand that, it's going to help a lot. Okay. I don't think I changed anything, but not that I would have pulled anything. So yeah, let's go ahead and get started. I'm just going to open this up in code. Let's see here. All right. Split this up so we can start yarn. So seeding to client, yarn start, and Rails SHP 3001. So let's kind of review what we did. So yesterday, remember, we kind of set up this starter project where we had React Router set up and Axios. And we're doing a little Axios call to our things. But as far as the assignment, we haven't done anything on the front end. We've done all the stuff on the back end where if I go look at my controllers, so we have a user. User has many grades, has many skill through grades. Our user controller is all filled out. That we just copied and pasted it because it's just kind of like our generic controller actions, CRUD actions. We did the same thing with our skills controller. So that's all there. So we should be able to hit all of these routes like API, users. So what's the error here? I'm getting a saying React Router 404 path not found.
Should you be in localhost 3001?
Yeah, I should be. So this is me trying to like go to API/users in my React project. And we have this set up in our React, in our app.js. If we don't match any of these paths, we're going to get this React Router 404. So that's just the front end stuff. So yeah, Sydney said we need to go to localhost 3001 API/users. And then that's going to hit our API. There's our users. We could grab our skills. There's all of our skills. And then we also have grades. Something I want to do, and this is not in the notes, but I kind of want to spend some time just maybe doing a little brain teasers with this data. So we kind of have, now that we're kind of getting back some interesting data, or we can get it in interesting ways, I want to kind of just like experiment and look at some of this. So let's look at our grades controller. So we have this index method, and this is what we did at the end of yesterday. We created this grade all and then some method, which is our custom class method right here, where we get all of our grades and then we map over them and kind of create our own little custom thing. Now, I'm just going to say this. This is a bad way to do this.
This is kind of mimicking what we would do with SQL if we had it, right? Am I understanding right?
Yeah, it is, well, behind the scenes, we're using SQL here. Like behind scenes, using SQL, but in a bad way. And let me just do like a puts here, just so we can like see like our mapping. So we're gonna do this map, and I'm gonna just put these like to like starting and end, just so I can see where in my console what's going on. And okay. So I'm gonna go refresh this API call. Oh wait, I do not. Oh. Okay. What happened here? It's saying end. And so then I set this equal to X and then X. Why do I need to?
Was Ruby doing an implicit return?
Yeah, Ruby's implicitly returning this last thing, and I want it to return this grades.map. So I need to store it to a variable and then return it. Cool. And then we're back. But now I want to go to my server. See if I can see those logs. And right here. Can't find out the stars. Why is it not showing that? You don't have to do this. I'm going to delete these when it's done, but I don't know why it's not logging those. Anyway, I can see it all right. Let's just see if I can find these. Yeah, it's not logging those for some reason. But why this is bad, we can see this right here. What this is this is all the SQL commands. And I can just restart my server just so I do have a point to compare this to. Okay. So that's how many SQL calls I did for my API grades. Started doing API grades and then bam. These are all SQL commands. There's a lot of them. Versus like if I were to just do, I'm going to comment this out and just like return grades here and do grades.all. Let's just stop that so we have that for reference. Refresh this. Oh, X is undefined. Okay. Okay. Now there's only like one of these. Where this one, where I'm doing all those mapping, like it's doing all these SQL commands. So this is bad, and you might see this term. So this is just like a brief intro. When I do it like this is what's called like an n+1 query. Where n, like, I kind of just want to be doing one query for my SQL, but here I'm doing, like when I do grade.score and grade.user and grade.skill, or grade.user and grade.skill, those are actually doing SQL calls. So I'm doing a whole bunch of SQL right here. And if I had a big database and I wasn't just returning like 50 things, but I was returning 1,000 things, we're gonna see this act slower. And maybe we'll do that. We'll like seed our database to be huge. So then this will actually take some time. But that'll be nice because I kind of want to do a spinner today on our front end. So I kind of want like an inefficient backend call. So n+1 query, n is going to be like the number of extra queries. And this is generally a bad thing. When I do grade.all, that's like one query to my database. When I set this equal to grades and then I map over them, well, now these are going to do a whole bunch of queries. And okay, so I just want to, just so like you don't like do this in a job interview or something and then you're like, well, James showed me how to do that. It's not a good way to do it. Cool. But now you might get that n+1's kind of another tricky thing to kind of understand. So this is like your first kind of exposure to that term with in particular with databases. And just a basic math thing. Let's talk more because let's do a little. This is totally off topic. But I just want to give you a taste of big O notation because since we're talking about this variable n. Let's say I have an array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I give you the brain teaser, I give you in an array and a number, and you have to tell me, and that function should return true or false if that number is in there. So I give you this array and this number, and you need to return true or false. Now we're not going to write this function, but what I want to talk about is the big O, how many operations, or like what is the cost of this function? And let me just write it really quick, so this is going to be easier. Def is in array, so this takes an array and a number. How do you think we're going to do this? This one's just go through each of the things. And, we could say like if n equals num, return true. And down here we'll do false, right? I'm just going to go through each of the numbers and just compare. Does the thing I'm looking at, does it equal the number I was passing it? Let me not call this number either. I'm going to call this X. Let's see why in 1 second. So if the thing I'm looking at equals the number, then return true. If not, return false. And this is a thing, I'm kind of showing it also in Ruby, like I have to have the return there because I'd want that function to end once I found the thing, right? Like stop function, return true. Okay. So then I ask you, what is the cost of this function? Like how many times is this each loop going to run?
It's going to run 10 times.
10 times. What if it's that?
Then it'll run once.
It'll run once. What is it going to run on average? I mean, yeah, that's a little harder question.
Something like 5 though.
5. Yeah, especially like if I was trying to find the index. Let's say like I knew the thing was in the array and I wanted to find the index. And it's not like, yeah, if I don't, yeah, if I give this like a, crap, like say I want to find the index. So we could switch this to each with index. Let's just leave it at the each, but yeah, if I wanted to find the index, this would be like 10 divided by 2, because that's how long the array is. So on average, I'd have to like look through half of them. So there's this thing called big O notation, where it's kind of like a way to simplify the cost of algorithms. Algorithms. I still can't spell algorithms, and I'm a software engineer. Okay. So yeah, what if my array was like 11, like, or just, you know, some general length? What I'm going to say, I'm not going to say the length of the array. I'm just going to say n. Like n is the length of the array. Like you'll see this n variable used a lot. It's just like it's just a short for number. Like that's what it is right here, n plus 1. It's just the number of extra queries. This n right here is going to be the length of the array. And with big O notation, I don't care if it's like divided by 4 or divided by 8 or divided by 16 or 2. I'm just going to round this up to n. I'm just going to say it's going to take the length of the array, even though it would be like technically half. They don't, with big O notation, you don't really care about these little things. So yeah, this would take, if I want to find something in an array or see if something's in an array, it's going to take n operations. Maybe though, well, what about this array? You notice anything special about this array?
It's ordered.
Yeah, it's ordered. So, because here's how we're gonna, like, you gotta think about how a computer solves it. It's gonna have to look at each one. It's not like it can like see all these at the same time. It like looks at each one and then, you know, does it. But what if our array is ordered? what benefit does that give us, or what strategy could we use to now see if something's in our array or not?
You could have it start in the middle and compare that number to the number that you have. And if it's bigger than it, to go the other way.
Yeah, exactly. So if I want to see if my array is sorted, then I can start in the middle. And I can see, like, let's say our number is like, let's go back to 11. So what I can do is I can like go to the middle, like, sure, let's say 6 is the middle. And I can say, hey, does 11 equal 6? Like I can just check, are they equal? No. Well, okay, is 11 less than or greater than 6? Well, it's greater than 6. Well, since my array is sorted, I know I don't need to look at the rest of those values. And then I can go look at the middle value here. Does 11 equal 8? No. Is it greater, less than? It's greater. So now I don't need to look at those values. And now I'm down to 2 values. And then I can just compare those 2 values, find that it's not there, and then that's false. So let's say like I had a million things, dot, 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 all the way to a million, or even a billion. Doesn't really matter, let's just say a million. Who knows on average how many looks that would be? Or give me just give me a guess. Let's say it's like, let's do a billion. And it's sorted. What's like the max number of things you're gonna have to look at? Any guesses? It can be like a range, like, oh, 1,000, 100, a million.
500,000?
500,000?
Yeah.
There we go. So for 1,500,000,000, anyone else?
I'm gonna guess low.
Guess low, guessing low.
You're asking how many, so if it's sorted and you do that same thing you did before where you check the middle one, 50?
50. Okay. Yeah, I don't know off the top of my head. It's probably around 50. I think it's like 24. But what the equation is, because yeah, why it's low is because think, if we have a billion, we start at a billion and then we just divide that. So it's half of a billion, 500 million, that's one time. Then 250 million, then 125 million, then 64 million, then 32 million. I don't know, 15 million. Like it gets small. It gets small pretty quick. Like 6 operations into it, we're like down to 6 million, 3 million, 1 million. I'm skipping here, but 500,000, 250, 125. Yeah, it's going to be around like 20. So does anyone know the math? Like what's that when we kind of like break things up in half? It's kind of like the opposite of exponential growth. Does anyone know that term?
Is it like the log, the natural log or something?
Yeah, that's your log. So this is going to be a log n. So if I do a log of a billion, that should give me the answer. It might have to be log base 2. How do I make this more? Okay, I'm just going to go to Google. Log of a billion.
You would have to do base 2
Yeah,
because log is 10 by default.
yeah, this would be log base. So this would be like dividing it by 10. So you start off at a billion and divide it by 10s 9 times. Log, how do I do that? base 2. Yeah, it's like 29. So log base n operations are awesome because they're fast. N operations are linear, those are all right. What if I had like I had an algorithm that did this? Do y. So I have my array and I'm just looping over it twice. So I have a nested loop. So we're talking about big O notation. So we've seen log n operations. We've seen n operations. What about this one where I have a nested loop? How many times is this going to put hello? And let's just say my array is n length. I mean, let's just say it's 10. Let's use an actual number. This might make it easier. If my array is length 10, how many times are we going to put hello?
100 times.
Yeah, 100 times. So that's 10 squared.
So yeah, n squared.
So yeah, that would be an n squared. And that is getting, we actually have one that's like one operation. That is like the best. This is better. This is okay. This is bad. There's actually one in between here that's n log n. This one's actually, n's pretty good. N is good. There's one called n log n, so it's the length of the array times the log of n. This is getting, that's okay. N squared is bad. There's also one that's 2 to the n. That's horrible. Because if we had an array of 10, that would be 2 to the 10, which, I mean, that gets big once n gets big. And then there's like, I forget what the other one, there's like another one that's like 2 to the like n factorial, which is just, yeah, ridiculous. Like these ones you probably never want to avoid at all costs. Sometimes you have to use like an n squared one, but we're always generally shooting for kind of in this range. But yeah, as I was talking about like arrays and sorting arrays yesterday, there's like it's like been proven you can't, for like an array that's just randomly sorted, you like can't do better than that. There's like no possible way. If it's like partially sorted, there's some algorithms that like can be in, but so. I'm going to select this out. There's like, yeah, very basic big O notation. It's not huge now, just since we kind of got on the topic. But you might, part of an interview question might be to like, they might ask like, what's the complexity of that algorithm? in big O notation, and they're looking for one of these answers. But I've never been asked that in a interview. You definitely would if you went to like Google. Google would definitely ask you, or they might say, oh, hey, you solved that as an n squared, but do you think you could solve that as an n log n algorithm? That would definitely be a thing Google would say to you. Yeah, on that note, let's take a little break. Let's doing some tangents here. I think like a lot of these things, I really think coding is the type of thing where you kind of get exposed to these things just a little here and there. Don't feel like you have to go learn big O notation right now. Just want to like plant that seed in your brain. So the next time you see it, you're like, oh wait, I remember James talking about that. I don't remember anything about it, but at least you remember the general idea. Cool. Let's come back at 10:30.